Hi everyone, we're going to do some more work with polynomials. In this section, we're going to learn how to divide polynomials. And the first part takes up a lot of paper, but I think you already know how to do it. It's using long division just like you learned in elementary. The same type of process for dividing that you learned in elementary school, you can apply to polynomials. And I'm going to show you how with this equation, 4x squared plus 23x minus 16, I'm going to divide that by x plus 5, and I'll show you how it works. Okay, so I put the large polynomial inside a division box, 4x squared plus 23x minus 16, and my divisor, what I'm dividing by, out here in front, x plus 5. So my first task is to see how many times this will go into this. Break this polynomial into pieces, and the same thing with here. Ignore the plus 5. Just only pay attention to the first term of this divisor. In this case, it's x. And only pay attention to one term at a time in here. So you're going to put x into 4x squared. And how you think about that depends on you. You can think, what's 4x squared divided by x? Or you could think x times what would be 4x squared. Anything like that that you want to, x goes into 4x squared how many times, however you want to think about that. But x times 4x would be 4x squared. So I'm going to write 4x up here. Then I'm going to do just what I did, just what you did in elementary school. I'm going to take this and I'm going to multiply it by x plus 5. So 4x times x is 4x squared. I'm going to write that here, 4x squared. And 4x times 5 is 20x, so plus 20x. And I'm going to do just like I did in elementary school. I am going to subtract that out. Here's where you're going to make your mistake if you're not careful. Because you're not just subtracting one term, you're subtracting two. You have to subtract both. This has to be subtracted. This is where people will make mistakes. So 23x minus 20x would be 3x, positive 3x, and 4x squared minus 4x squared, there, my x squareds disappeared. Now I can bring down my negative 16, and I can repeat this process. X into 3x, ignore the rest. X into 3x is just positive 3, so I'm going to write positive 3 up here. Positive 3. And now 3 times x plus 5, remember just like you did in elementary school, that's 3x, and that's plus 15. Got to multiply it by both. Plus 15. It's distributive, right? 3x plus 15. Subtract that out. So negative 16 minus 15, negative 31. This sign changes. 3x minus 3x is 0. X cannot go into negative 31. This is my remainder. So what this is my answer, this is my quotient. My quotient is 4x plus 3 with this remainder of negative 31. And I didn't review division with numbers, which would have been helpful. A lot of times if you have a number left over, it's this over this can be how you would show your remainder. I don't know if you remembered that. But you could say plus our remainder, which is negative 31 over x plus 5. That's our remainder, and there we go. Or if you want to just take off this plus and put a minus 31 over x plus 5, you can do that as well. But that's your answer. So 4x plus 3 plus the remainder of negative 31 over x plus 5. That's long division. I just checked the book and it just shows r of negative 31. That's fine too. This is technically better. But if they ask on the computer what this is remainder negative 31, then just give them that. That's great. Let me walk through another one just a lot quicker now that I've done the first one, just to review. And you can, if you want, pause, do this really quick, and then watch me walk through it just to see how well you guys do. But it's 3x squared minus 29x plus 56 divided by x minus 7. Okay, here we go. So x into 3x squared is 3x. When I multiply that out, that's 3x squared minus 21x. Subtract that away. This becomes a positive, and that ends up being negative 8x, and that disappears. Bring down my 56. All right, x into negative 8x is negative 8. Multiply this by negative 8, negative 8x plus 56. Well, look at that. Isn't that sweet? My remainder is a big 0. I have no remainder, so my quotient is 3x minus 8. Okay, on that last problem, I divided the polynomial by x minus 7, and I got 3x minus 8 with no remainders, which means if I go backwards, if I take x minus 7 and I multiply it by 3x minus 8, I will get that original polynomial that I divided. So this is a factor of that polynomial. If I divide something out with no remainder, then it's a factor because it just divides out super evenly. So we're going to use that knowledge to determine, is this a certain expression, would it be a factor of this big polynomial? Let me show you what I mean. Okay, I have this polynomial, 3x to the 4th minus 4x cubed plus 12x squared plus 5. And my question is x squared plus 1 a factor of this polynomial? So to find that out, I would divide this by this and see if I get a remainder of 0. If I get a remainder of 0, it's a factor. If I don't, then it's not a factor. And so I can answer yes or no. There's a few things I want to show you in doing this division. Notice in this quartic, I have x to the 4th, x to the 3rd, x squared, but I have no single x. Do you see that? Also in my divisor, I have x squared plus 1, but no single x. That doesn't necessarily have to be a problem, but sometimes it's easier if we put placeholders. Because when I was dividing before, did you notice that I was putting things under like terms? We will have some single x's to deal with. And so it might be easier to rewrite this as plus 0x plus 5. Plus 0x plus 5. Not necessary, but helpful. Okay, not necessary, but helpful. The same thing here. I can do the same thing. I can write x squared plus 0x plus 1. Again, not necessary, but helpful. So I'm going to go ahead and show you with those 0x's. If you don't have the 0x's, then you just have to remember to keep things under like terms so that you don't combine terms that don't go together. All right? So let's go ahead and do this one. Again, only worry about the x squared, one term at a time. X squared into 3x to the 4th would be 3x squared. So I'm going to write 3x squared. Now I'm going to multiply this times this, each and every term. 3x squared times x squared is 3x to the 4th. This is just 0x cubed, and this is plus 3x squared, plus 3x squared. Do you see why people would say that's plus 0x cubed? Because 3x squared times x, 0x would be 0x cubed, and I had to put this x squared over here. Some people need that 0. It's not necessary, but there you go. That's why they have it. All right, now I'm subtracting. Subtracting. So all these signs get changed. 12 minus 3 is 9x squared. Negative 4 minus 0 is negative 4x cubed. That's a positive, and that disappears. There we go. Now, x squared into negative 4x cubed would be negative 4x. Negative 4x, multiply that. That's negative 4x cubed times 0x squared and negative 4x. And I subtract that down. So I have 0x. I forgot to bring my 0x down, sorry. 0x minus a negative 4x would be a positive 4x because I'm subtracting the negative. By the way, if I hadn't written that 0x, just know that I'm subtracting a negative 4x from no x's at all, so it would still be this. I would just have to know it in my head. 9x squared minus none is positive 9x squared, and that disappears. Bring down the 5. X squared into 9x squared is plus 9, so that's 9x squared. Now I'm multiplying times 0x plus 9. And when I subtract this out, I end up with negative 4x minus 4. I have a remainder of 4x minus 4, which tells me x squared plus 1 is not a factor. And now I want to see if x minus 2 is a factor of x to the 5th minus 32. So let's go through that long division process again. X into x to the 5th would be x to the 4th. I have no x to the 4th to write it above if I don't have that placeholder, do I? Okay, let's go ahead and multiply. This is x to the 5th, and this is minus 2x to the 4th. Subtract that out. So I don't have any x to the 4th, so 0 minus a negative 2 is a positive 2x to the 4th, and there's my minus 32 that I can bring down. Now, x into 2x to the 4th is 2x to the 3rd plus 2x to the 3rd. Multiply it. 2x to the 4th minus 4x cubed. Subtract that out. I have 0x cubed minus a negative 4x cubed, so that's positive 4x cubed. Bring down my 32. Do you see how I don't have the 0 placeholders? But if you still are looking for like terms, this is how you would do it without the placeholders. All right, x into 4x cubed is positive 4x squared. And 4x squared, that would be 4x cubed minus 8x squared. So when I subtract that out, that's positive 8x squared minus 32. X into positive 8x squared is positive 8x. So 8x squared, I'm multiplying now, minus 16x. Subtract that out. I'm running out of room, aren't I? I get positive 16x minus 32. X into 16x is plus 16. So 16 times x is 16x minus 2, negative 32. My remainder is 0. Whew, I just wiped myself right off the screen. So yes, the answer is yes. X minus 2 is a factor of x squared minus 32. Used up a lot of board, but we were able to figure it out. So if I had written x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 32, then I would have had like terms to subtract from. But I was able to do that anyway. Just be careful. I had to subtract a negative each time. Did you notice that I changed the signs because I was subtracting? Common mistake. Be careful. By the way, now that I know it's a factor, the next step is to write this as 2 factors. So I would write this times x minus 2 instead of that. These are the 2 factors. So when they say write it as a product of 2 factors, they mean write this instead of that. Okay? Okay, now I get to teach you one of my absolute favorite things that I ever do in Algebra 2. It's called synthetic division, because face it, all that long division is not our favorite. I bet you didn't like it in elementary, and you sure don't want it to come back here in Algebra 2, so we're going to find a way to avoid it. Some advantages to being at an Algebra 2 level, and we're going to avoid it with something called synthetic division. When you learn synthetic division, it's just wonderful. So be really careful, listen specifically to everything that I tell you as I explain it, and this will become one of your favorite tools in algebra. Okay, we're going to take this polynomial, x cubed minus 14x squared plus 51x minus 54, and we are going to divide it by x plus 2. Now, the first thing that you need to know about synthetic division is that you can only use it when you're dividing by a simple binomial like this, x plus or minus something like this, because we have to use the zeros, not the factors. So what you need to do then, if it's x plus something or x minus something, then you can set up synthetic division. And you're going to set it up by its zero, not by its factor. So the first step that we're going to do to make this easy is we're going to get rid of all our variables, and we're just going to deal with the numbers. That means if we have some missing terms like we had before, and I showed you how you could put the zero placeholders, in synthetic division, it's not optional. You have to have the zero placeholders, otherwise you'll get the wrong answer. So that's step number 1. Set up all the coefficients using 0 as placeholders when necessary. So this is a 1. The coefficient in front of x cubed is a 1. In front of x squared, it's a negative 14. In front of single x, it's a 51, and then in 0x, it's a negative 54. So I've listed just the coefficients, and I'm checking. I have 3, 2, 1, 0 x's, so I didn't need any placeholders. And then instead of drawing my division box like you're used to, I'm going to have you flip it upside down, kind of like this, but leave some space, okay? And now you're dividing it by x plus 2. Remember we're getting rid of the variables, so I don't want the x plus 2. I want its 0, which is negative 2, and I'm going to put negative 2 here. Okay, let me move my x plus 2 out here. So there's my 0. Now here's the steps for synthetic division. Step number 1, bring the first number down. So take this first one and bring it down. Okay, now you're going to take this divisor and multiply. You're going to multiply. Negative 2 times 1, you're going to write your answer here. Negative 2 times 1 is negative 2. Okay, put it there in the next column. Add straight down. This is negative 16. Multiply. Negative 2 times negative 16, positive 32. Add straight down. 83, positive 83. Multiply. Negative 2 times 83 is negative 166. Add straight down. This is 10, 12. It looks like it's negative 220, and you are done. Now let me show you what your answer means. This represented x cubed, x squared, x. We divided one of the x's out. So this answer is x squared. So this means 1x squared minus 16x plus 83, and this is our remainder. Our remainder is negative 220. And that's your answer. That's all you had to do. That's how to use synthetic division. Okay, now that we've seen how this works, let's do it again. Let's take this polynomial, x cubed minus 57x plus 56, and divide it by x minus 7. Remember, your first step is to look, do you need any placeholders? I have x cubed, but sure enough, I'm missing x squared, so I'm going to need a placeholder for x squared. So let's write our numbers, our coefficients. This one is 1. I have 0x squareds, negative 57, single x, and 56. So there are my coefficients. I'm going to take my box, my upside down division box. I want to divide by x minus 7, so I need to change this sign because I want to divide by the 0. So this is going to be a positive 7, and now I'm ready to go. So I bring down my first number, my 1, multiply, 7 times 1 is 7. Write my answer here, add straight down, that's 7. 7 times 7 is 49, write down 49 here, add straight down, that's negative 8. 7 times negative 8 is negative 56, add straight down, and that's 0. This was x cubed. That means my answer is x squared. This is x squared, this is 1x, this is 0x. So my answer is x squared plus 7x minus 8. My remainder is 0, which means x minus 7 is a factor of this polynomial, and this times this equals that. That's synthetic division. Okay, we can use synthetic divisions to solve problems now. In your book, they show a box, a picture of a box, and this polynomial here represents the volume of that box. When you remember to find a volume of a box, you multiply the length times the width times the height. You are given one of the dimensions, it's x plus 5, but you don't know the other two, and they say, what are the other two dimensions of this box? So in order to find that out, we need to divide, since the length times the width times the height is this, divide this out, and what you'll have left is what the other two multiplied would be, okay? Let me show you what I mean. So let's use synthetic division because it's much quicker and easier to see what happens when I divide out that this expression x plus 5. So 3, 2, 1, 0. I don't need any placeholders. My coefficients are 1, 7, negative 38, and negative 240. I draw my box, and I'm going to put my 0 up here, which will be negative 5. Okay, did you follow all that? Bring down my first number, multiply. Negative 5 times 1, write my answer here. Add straight down 2. Negative 5 times 2 is negative 10. Add straight down, negative 48 times negative 5 is positive 240. Good thing it's positive. 0. This was x cubed, so this represents x squared plus 2x minus 48. Can I factor that? I can. This 6 times 8 is 48, right? So this is x plus 8 times x minus 6. And that would, those are the factors for this. So now I know my three dimensions. X plus 8, x minus 6, and this one here, x plus 5. And I have fully factored this trinomial. That is super cool. There is one other really awesome aspect about synthetic division that is super, super helpful. Let's say we have this function. P of x is x to the 5th minus 2x cubed minus x squared plus 2. And you are asked to find what's the value of this polynomial given a specific x. In this case, we want to know what's P of 3. In other words, what's the value of this when x is 3? So you could substitute 3 for each x and go 3 to the power of 5, 3 cubed minus negative 2, x squared, subtract that, add 2, see what you get. But synthetic division will give you the answer. If you set up a synthetic division problem and you use 3 as your number out front, then your remainder, at the end, the remainder is what the value of this polynomial at 3 is. Super cool. So let's do it. Look for placeholders. I'm missing an x to the 4th, so I need a 0. And I'm missing a single x, so I need a 0 here. I need 2 placeholders. Please be careful. So let's do that. So my first one is 1, then a 0x to the 4th, a negative 2x to the 3rd, a negative 1x squared, a 0 single x, and a 2 of a 0x. And there's my box, and I want to divide by 3. Don't use the opposite sign. This is the 0, so I divide by 3. Okay, we'll walk through this again. Bring down the 1. Multiply, write down your answer. Add 3. Multiply, 3 times 3 is 9. Write it up here. Add, that's 7. 3 times 7 is 21. Add, it's 20. 3 times 20 is 60. Add, that's 60. 3 times 60 is 180. Add, you get 182. Guess what P of 3 is? It's 182. Now, wasn't that a lot easier than plugging in 3 to all your x's and finding out that that's the answer? So the value of this polynomial, or this function, when x is 3, is 182. Okay, so I've covered everything that this is in this section. The last thing I'm going to leave you with is the lesson check. X to the cube plus x cubed plus 5x squared plus 11x plus 15. I want you to divide that by x plus 3. And now, since I saved this to the end, you can use any method you want. You can use long division, or you can use synthetic division, whatever works for you, but bring in your answer for that for your lesson check, and we'll be good to go. I hope you enjoyed this. Synthetic division is just a great tool. So I'll see you guys next time.